everyone, this is Ms. Segovia. I'm going to walk you through the foldable for dihybrid crosses. So the way I set this up, it was a big paper and you just fold over, so it'll look like that when you received it. You just cut it and fold it over and do the little windows. I did it like this so you can have a little extra workspace behind each window without your paper getting too overwhelmed. So these questions on here, many of them are actually taken off of STAR exams or inspired by actual STAR exam questions. You will see dihybrid cross questions on the STAR exam, so it's very important that you understand how to work these. In our first question, if several pea plants with the genotype big T, big Y, little y are crossed with pea plants with the genotype big T, little y, what percentage of the offspring will be expected to have the big T, big Y, little y allele combination? So if you remember from a previous lesson, it's better to work this in smaller Punnett squares versus the ginormous Punnett square. So let's go ahead and do that. For our T, we have big, little. So we'll just open up our little window here to give us some workspace. So big T, little t, and again, what was that? Big T, little t. So I got to do my bigs over here. And then I'll just write out my cross. And then for my other is y's. I had big Y, little y, and then little. So let's draw upon it for my y's. Big Y, big, little. So that's big, little. And then the question is asking us, what is the expected percentage for big T, big Y, little y? So we want to know big T, big Y, little y. And so the easiest way to do that is the fraction method. So what percentage of, or fraction, I'm sorry, of our offspring would we expect to be big T? Well, out of our 4, 2/4 are big T. For big Y, little y, we also have, that's big, little, 2/4. And to find our answer, we just multiply those. So 2/4 times 2/4, we have 4/16. We can reduce 4/16 down to 1/4, which is equal to 25%. So your correct answer for this question is A, 25%. On the second question, if two dragons with the genotypes big F, big W, and little f, little w are crossed, what percentage of the offspring will be expected to have big F, big W allele combinations? I feel like an auctioneer when I do this. All right, so let's do our mini punnets. Big F, and then little f. So big F, little f. Work out that punnet real quickly. And then big W, little. And if I'm going too fast when I draw these out, feel free to pause. If you're still super confused by how to do this, please come ask. I cannot read your mind to know if you're really struggling on this one. They want to know, what is our combination? Big F, big W, little w. So big F, big W, little w. Well, big F, out of my 4, I have 2/4. My W's, also 2/4. So that is 4/16. And again, 4/16 can be reduced down to 1/4, which is, again, 25%. On our third question, in a dihybrid cross, if you have big A, big little b, crossed with the same thing, what fraction of the offspring will be homozygous for both recessive traits? So let's go ahead and draw out our tables. We have 2 heterozygous crosses. And what you might find eventually as you start going through these and practicing them a lot is that you can do them in your head. And so while I love to see your work, if you get to the point where you can do them in your head, that is fantastic. As many of you might already know, that it is a 3-to-1. You get 3/4 showing the dominant and 1/4 showing the recessive. All right, so they want to know in here, homozygous for both recessive traits. So that means the recessive is the little letter, homozygous means both little letters. So they want to know what our little a, little b fractions odds are. And so in little a, right here, 1 out of 4 has that trait. In the b's, 1 out of 4 has that trait. And so multiply those together and you get 1/16. And that is answer A. On this side, if cats with the genotypes big W, little w, big F, and big little are crossed, what are the expected genotype percentages? So let's go ahead and draw out our Punnett squares. I already forgot. Big W, little w, big W, little w. Big little, big little. And our F's, big F, big F, big F, little f. Sorry. Oh, that's wrong. What is it? Big, little. This is interesting. When we do this, notice that all the heterozygous in the F. And so we have a 100% chance of being this. So what are all our possible genotypes? Well, we could have big W, along with big F, little f. And what are the odds of that one? Over here we've got 1 out of 4 being that, and 4 out of 4 being this. So that comes out to 4/16 or 1/4. We have our heterozygous W's, so big W, little w, and again all our F's are the same. On here, 2 out of 4 and 4 out of 4, so that is 8/16 or 1/2. And then we have little w, big F, little f. And so we have 1/4 being little, and still 4/4 being this. So that is equal to 4/16 or 1/4. And so the question asks us, what are the expected percentages? So if we've got big W, big F, little f, that one 1/4 works out to be 25%. Big F, little f, that was 1/2, so that is 50%. And then little with our f's is 1/4, so that is 25%. And that's your correct answer for the cat question. And our fifth question. In Cocker Spaniels, the allele for a black coat color, big B, is dominant over the allele for a brown coat color, little b. If a brown Cocker Spaniel is crossed with a heterozygous black Cocker Spaniel, which of the following genotypic ratios can be expected? So in this one, it's not a dihybrid. If you read that closely, we're only looking at one trait, which is the coat color. And so the black big B is dominant over brown. So we have a brown Cocker Spaniel. So since it's brown, that means it's recessive. It's the little b. If one of the parents is that means that they are little b. And they tell us that the black parent is heterozygous. So that means they must have the big and the little. And then they're asking us just to do a Punnett square on this. So if we draw out our Punnett square, we have little b, big B, little b, and we can just go ahead and work out our numbers here. So we know that on here we would have 2 out of 4 being black. That's the big B, little b. And we would have 2 out of 4 being brown, which is the little b. So if we go back over here and look, which one best matches with that? Well, the big B, if you notice, none of the offspring have that trait, and B, C, and D all show that trait. The only one that matches is the 0 big B, 2 big littles, and 2 little littles, and that is exactly what we have. And so A is your best answer there. Hey everybody, let me show you how to work that bonus question. So on this one, in a quad hybrid cross, what fraction of the offspring would you expect to be this if the parents are this and this? And so to figure that one out, we need to do 4 Punnett squares. So for each of the traits, we need to take a look at what are the odds of having each potential outcome. Now I'm doing it on this little separate sheet out front just so I don't have to keep flipping back and forth because there's a lot of flipping on this one. So in our E trait, we have one parent is homozygous dominant, the other one is homozygous recessive, and so we can go ahead and work out that one. You can see actually all of them would end up being heterozygous. In our F trait, we have one parent is homozygous dominant and the other one is heterozygous. Oops, should be capital F, lowercase, capital, 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 lowercase. And then we have our G trait. One parent is homozygous dominant, the other one is homozygous recessive. So again, all our offspring would be heterozygous. And then our H trait, we have homozygous dominant parent and a heterozygous parent. Alright, so if we want to find out what are the odds for the offspring, let's just go ahead and rewrite the offspring here. We're wanting to know what are the odds of it being big E, little e, getting it from right there. And according to my table, that is 4 out of 4. What are the odds of it being heterozygous for the F trait? And so if we look at the table, that is 2 out of 4. What are the odds of it being heterozygous for the G trait? And so on here, that is 4 out of 4. And could you put 1 for these two? Absolutely. You can go ahead and reduce that down if you want. What are the odds of it being heterozygous on the H's? And that is 2 out of 4. And so then what you have to do here is multiply. Let's go ahead and turn our 4 fourths. We're just going to X that out. We're going to call those 1 so we can make our math a whole lot easier here because that is what they would reduce down to. And so 1 times 2 times 1 times 2 is 4. And then 1 times 4 times 1 times 4 is 16. 4/16. And so 4/16 reduced down to 1/4, or we would have a 25% chance overall of having our offspring being completely heterozygous with a parent that's totally homozygous dominant and a parent that is a mix of the other ones. And that's how you work the bonus question.